than circles. They're a little more of an oval shape. Okay? The big difference between ellipses and circles is instead of one central point being the same distance to all points on the outside, there are two focus points that are the same. If you add up their distances to a point on the outside of your ellipse, it always remains constant. Major axis is the longer axis of symmetry, where minor axis is the shorter. So if we were to draw this, and we were to fold it in half like hot dog ways, that's the major axis. Fold it in half hamburger ways, that's the minor axis. Major is longer, minor shorter. The center is where the two axes intersect. Vertices are the endpoints of the major axes, and the co-vertices are the endpoints of the minor axes. Okay? So we are going to label all of these points on the horizontal ellipse together, and then I want you guys to try it on the vertical. Okay, first I'm going to mark right here, that is the center. Here's a focus point. Here's a focus point. These are vertices, or each one is a vertex. Because they are on the major axes. And these points right here are my co-vertices. Okay, you guys try right now. Got like 1 minute or less to label all of that on vertical ellipse. If you don't feel like you can write that fast, just write the first letter. Co-vertices? Okay, so you got this right as the center, right? And these are your focus points. What are these right here that I'm drawing? Co-vertices, good. Because they are on the smaller axes, and these are vertices. Okay. So now we're going to start to break down how to figure out what the equation is. Can you pull the door? Okay. We're going to call the vertices positive or negative A, units from the center. And we're going to call the co-vertices positive or negative B, units away from the center. Okay? The length of a major axis is 2A. So get that A always goes with the major axis. And 2B is the length of the minor axis. Okay? The focus points are plus or minus C units away from the center. The formula to find this is C squared equals A squared minus B squared. Notice this is not the Pythagorean theorem. What is it missing? What's there instead? Right, instead of a positive. Okay, so now we're going to write it in standard form if the center is 0, 0. Okay, this is important because it is different if it is not. So we're going to say x squared over a squared plus y squared over b squared equals 1. Now, the equation. Remember yesterday when we talked about circles? We had x squared and y squared. Same thing. Okay? Now I'm going to change this, and you're going to tell me why I would ever do this. X squared over b squared plus y squared over a squared equals 1. Why do you think I would change this? They're both correct. Why would it be x squared over a squared and then x squared over b squared? Yes, this one's horizontal, this one's vertical. So your A, or your major axis, needs to be underneath x if it's horizontal, and underneath y if it's vertical. Okay? Now, most of the time, the center is not at 0, 0. So what do we do if it's not? We're going to change the formula slightly. It's going to look very close to circles, where we have x minus h squared over a squared plus y minus k squared over b squared equals 1. Or if it's vertical, x minus h squared over b squared plus y minus k squared over a squared equals 1. Questions about any of that? Yes. Okay. All the parts of the circle formula or this formula? Okay. So this is telling me half my circle, forming half my circle, or half my ellipse. This is forming the other half of my ellipse. Okay? This is A, is telling me the length of, well, it's telling me where my vertices are for my major axis. This tells me what my vertices are for my minor axis. Okay? And then when we add the h and k, they just change where the center is. All right? So now we're going to try this out. I am not going to do all of these because there will not be enough time in class to do them all. But I am going to do some. Okay. So here we are. We're starting with our number 1. We have x squared over 4 plus y squared over 36 equals 1. So my first question to you is, which one of these is A squared? 4 or 36? Oh. 36. A always has to be the biggest one. Okay? So what's the square root of 36? What kind of 6? Plus or minus 6. Okay? And what is b squared going to be then? 4, and b is going to be plus or minus 2. So we have found, and I'll show you how to put this down, the vertices, the co-vertices, and the center already. Now we need to find the focus points. Okay? The foci. So that's that formula that I showed you that's not the Pythagorean theorem. C squared equals A squared minus B squared. So 36 minus 4 is 32. C squared equals 32, and I'm going to square root both sides. And I'm actually going to find the decimal because I'm going to have to graph them. So I get C is plus or minus 5.66. Okay, that's my work. Now I'm going to write them out in a logical way so that I can actually graph. All right, so I'm going to zoom in a little bit more. All right. Just a reminder, there is no charging your phones in my class, and if you do, I will come around and get your charger. So that's my warning. The center is 0, 0. I'm not adding anything to x or y. My vertices are going to be 0, negative 6, and 0, positive 6. My co-vertices are going to be 2, 0, and negative 2, 0. And then my focus points are going to be 0 and 5.66, 0 and negative 5.66. Any questions on how I got any of those? Okay, so we're going to skip number 2, and we're going to go to number 3. All right. So I'm going to ask you the same types of questions again, and you're going to learn to ask these for yourself. Which one is A?
We're not doing 2.
We're not doing 2. We're doing number 3.
49.
49. A squared is 49, so A is plus or minus 7. So B squared would have to be 9. And so B would have to be plus or minus 3. Okay, so now we need to find C squared, right? C squared equals 49 minus 9. So C squared equals 40. So we square root both sides, and again, we want to put it in its decimal form. So C is approximately plus or minus 6.32. Okay, here's where it gets complicated. We're going to add something new. We have a different center, and I'm going to show you how that's going to change things a little bit besides just the center. Okay, so what is the center for this? -1, +2. Since the center is -1, +2, we have moved our whole ellipse over, right? So I am going to, for all of these, subtract 1 from the x, add 2 to the y. Okay? So instead of the vertices being 7, 0, and -7, 0, it's going to be 7 minus 1, which is 6, 2, and -7 minus 1, which is -8, 2. So far, so good? So if we change the center from 0, 0, whatever is my new center's x, I have to add to the x values. Whatever is my new center's y, I need to add to the y values. Okay? Yes? The center's right here. Just like what we did for the circles yesterday, it's the opposite of these numbers. Okay, what are my co-vertices? Does somebody want to try? What do I get for my co-vertices? Instead of -1, 5, and -1 what? -1. Okay. Anybody want to try the foci? Or foci? Or focus point? Or foci? What do we get? So remember, the C, okay, or the foci just goes along the major axes. So are we just changing the x value or the y value? Which one has the biggest number under it? The x has the biggest number under it, right? It's 49 underneath it. So that's my major axis, so I'm just going to change the x value. Does that make sense?
No, it doesn't.
The foci points are only on the major axis. They're not on the minor.
So it would be 8.3 to 5.32.
Good. 2. And? Because we could have the negative. So it'd be negative 7.32. 2.
I'm so confused.
Okay, so I took this point right here. This
Yeah.
has to be only the x value, right?
Yeah, I know, but what I'm saying is, I thought that was the y and the x is 0.
So the y is 2. So I still had to move it up 2.
Why did I put it where the x is?
Because I had to subtract 1 from it. Because this is along the major axis. I know the major axis is on the x, is going right or left, because the 49's under the x. Am I still losing you, Lawrence? Are you okay? Okay, now I'm going to graph this. So,
The first one?
did we not graph the first one? We might have skipped it. Do you want me to graph the first one real quick? Or?
Yeah.
Okay, let's go back to number 1. We're going to put a point at 0, 0. Then we point a point at 0, 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, negative 6. And we put one at positive 2, 0 and negative 2, 0. And then our foci are at 0. Oh, I did something wrong. Oh, I did it backwards. It's vertical. So this should be 6, 6, 2, 2. And this should be 5.66, negative 5.66, and it should look like this. There we go. Okay, we're going to graph another one, and I promise I'll do this one right the first time. How about that? Okay. Ready for number 3? So you guys, when you graph this, you should graph it literally in this order. Center, vertices, co-vertices, focus point. Kelly, this is being recorded, just so you know. You need to get out your pen or pencil and be writing down these notes right now. Okay, number 3. My center is negative 1, 2. So I'm going to 0, 0. I'm going to the left, negative 1, up 2. That's my center. My vertices are to the right, 6, up 2. To the left, negative 8, up 2. My co-vertices are to the left 1, up 5. To the left 1, down 1. My focus points are 5.32, and negative 7.322. Sorry, I'm looking at the time. I want to make sure we can get to 2 more problems. The focus points are the distance. They're the same distance. If I connected both of these to a point here, that distance is the same. This distance plus this distance is the same for every point on the ellipse.
They don't really got your graph.
Yes, but if you do not have them on graphing, you will not get full credit. Because I want to see that you can find. Like our solar system is not, like we do not go around the sun as a circle. We actually go as an ellipse. And that's been a constant issue because if gravity pulls you all in everywhere the same, why wouldn't it be a circle if the sun was the major focus of our gravity? Something has to be pulling us differently because it would change our structure. So there's been a lot of theories about why that is. All right, let's do problem number 6. So we're going to skip all the way to number 6. Okay. All right. Number 6. Does it kind of look like an oval? We'll work on it. All right, number 6. All right, does this look anything like the equation we need it to look like? What is the first thing you might notice that needs to be fixed? It's not in standard form. You're correct. It's not. What is the equal sign supposed to say? After the equal sign, it's supposed to say 1. So we're going to divide it by 144 so we can get it to say 1. It is not going to be a circle. It's going to be x squared over 16 plus y squared over 9 equals 1. Okay. So what is a squared? So what is a? What kind of 4? Plus or minus. B squared is then going to be? So B is going to be? Plus or minus 3. Okay, and how do I find C squared? 16 minus 9. So C is going to be what? Approximately plus or minus 2.65, excuse me. Okay. What's my center? Is there anything being added to the x or y on top? So 0, 0. Ooh, this makes it a lot easier, right? What are my vertices? Which one's bigger? The bigger number is underneath the x or the y? X. So my vertices are going to be 4, 0, and negative 4, 0, right? What are my co-vertices going to be? Good. And remember, the focus points go along the major axes. And so how am I going to list them? Am I going to list 0 first or 2.65 first? 2.650 and negative 2.650.
So why do you list the 2.6?
So would it be the y if a was under the y?
Yes. Yes.
Why does the 2.65 go first?
Because it's along the horizontal axis. So when it's horizontal, we talk about the x-axis. Okay, so I'm going to put a dot at 0, 0. I'm going to put another dot at 0, 4, 4, 0, 4, 0, and negative 4, 0. I'm going to put a dot at 0, 3, and a dot at 0, negative 3. And then I'm going to put a dot at 0, at 2.650, and negative 2.650. And then I'm going to draw my circle. That is my ellipse, since it's not a circle. Okay, guys, we've got time for one more. I want to do one more because we're going to start doing some complete the square with this. Okay. What part? Okay. Number 7. What is wrong with this? The first thing I notice is that negative 10x, so I'm going to stick it together. remember when I have an x all by itself, it's not being squared, I need to leave a space because I'm going to have to do complete the square. What's half a 10? What's 5 squared? So I'm going to have to add 25 to both sides of my equal sign. What is x squared minus 10x plus 25 factor? X minus 5 squared, good. Plus 4y squared equals 25 plus negative 9 is 16. Can I have anything on this side of the equal sign besides a 1? Sorry, I'll slow down. Okay, what do I do with this 16? Divide everything by 16. So I have x minus 5 squared over 16 plus y squared over 4 equals 1. What is a squared? So what's a? Plus or minus 4, good. What is b squared? So what is b? Plus or minus 2. How do I find out what c squared is? I say c squared equals 16 minus 4. So c is approximately 3.46 plus or minus. All right, what is the center? 5, 0. Good. So that means anything that has an x, I'm going to have to add a 5 to. Okay? What are my vertices? Are they going to be under the x, and I'm going to use that, or am I going to use what's under the y? What's under the x, right? Because the x is bigger. So I'm going to say 9, 0, 1, 0. So the co-vertices are just going to be 5, 2, and 5, negative 2, right? The focus points, do they go in the x spot or in the y spot? X. So I'm going to have 3.46 plus 5, which is 8.460. And negative 3.46 plus 5, which is going to give me 1.54, 0. And now I'm going to graph. I'm going to go 5, 0. And I'm going to go 9, 0. And 1, 0. I'm going to go 5, 2. And 5, negative 2. And I'm going to do my foci, which are 8.460 and 1.540. Okay, so your homework tonight is going to have some of everything on it for graphing it, okay? So you have the rest of the hour to begin that.